Okay, see Lindelof videos. AP Calculus, chain rule with quotient rule embedded. This is kind of what starts to happen as calculus starts to unfold itself. Initially, our professors teach us to use the product rule, the quotient rule, sum and difference rules. They give us the derivatives of all the trigonometric functions, and we tackle those things kind of one at a time. What tends to happen after that is the rules become a little bit more complicated as you have to use two rules to solve one problem. So this is that case. So if you remember, the chain rule says that d dx, the first derivative of f of g of x, f of g of x is actually equal to f prime at g of x times g prime at x. And this is what we're working from. This is what I want to say about this, that this part right here is the derivative of the outside function. This means the derivative of the inside function. So that's what we're going to do. I'm going to use u substitution. So I'm going to say let u, actually let me do it here. Let u equal g of x, and let g of x equal that inside piece, that inside function, which is x plus 5 over x squared plus 2, right? Well, if we said that, what we're saying here is that where we found that g of x part, we're going to substitute u. Where we found x plus 5 over x squared plus 2, we're going to substitute u. So there it is. I just put the u here. Now you can see that this function looks now similar to u squared. So we say, well, that function of u, f of u, is equal to u squared. Right? This 2 is this 2. This u is this, right? It's this outside piece that I'm taking the derivative of. So I'm going to go ahead and start to unfold this, and I'm going to say, okay, well, f prime at u would equal 2u. All I did was differentiate u squared, right? Here's where it starts to get interesting. As you can see right here, we need g of x. So g of x, we said, is the inside piece. Well, g of x is that inside piece, which is x plus 5 over x squared plus 2. Okay, this is where it gets really bad, because I need the derivative of this. I need the derivative of this thing to put here, right? I need to find g prime at x to plug in at g prime at x. And what that does is it causes me to have a separate calculus problem. So as we're working on one problem, we have to stop for a second and move off and take our problem with us. So what I'm going to do is do an aside of x plus 5 over x squared plus 2 and differentiate that. So I'm going to pretend just for a second that we have this new function, which is x plus 5 over x squared plus 2. Hopefully you're looking at that going, Charlie, wouldn't this be a quotient rule problem? The answer is yes. So I'm going to build this problem in anticipation of bringing it back to the other problem and plugging it in. So I'm going to do this. I'm going to say f of x is equal to x plus 5, isn't it? F prime at x would be equal to 1. That's the top function, is f of x. Now I'm just breaking this problem apart and saying, okay, g of x for this particular problem would be x squared plus 2. Of course, I think we can agree that g prime at x would equal 2x, wouldn't it? Now what I have to do, I know that you guys are thinking back and like, what happened to that chain rule problem? It's waiting for us, but we have to gather some pieces first. So I'm going to go ahead and gather those pieces. I'm going to use the quotient rule, which says that g of x, so x squared plus 2 times f prime at x, and f prime at x is 1, minus f of x, which is x plus 5, times g prime at x, which is 2x, sorry about that, right, all over g of x squared. So I have g of x, which is this mess right here, squared. Let me caution you right now, do not expand this. There's no reason to expand this. It's just going to confuse us later. So let's just leave it alone. Let's clean this algebra up, and we get x squared plus 2 times 1 is just x squared plus 2, isn't it? We get 2x times x plus 5 would be 2x squared plus 10x, isn't that right? Right, 2x squared plus 10x, right? So it would be 2x squared plus 10x, right? Going to distribute this negative sign through, which makes this negative, and this negative, doesn't it? So I satisfy those parentheses. I can take them down. I'm going to gather up my like terms here. I get x squared minus 2x squared is negative x squared, right? Minus 10x plus 2, right? As I clean that up, all over x squared plus 2 quantity squared. I'm just going through the algebra of this crap right now, right? And I'm going to get g prime at x right here, I hope. Right? So that is what we get, isn't it? So look, now this is what I'm doing here. Remember that problem that we were just on. I'm going to take all this crap back over there. I'm going to take all this back over there and do this problem. So, was equal to, let me look at it again, negative x squared minus 10x plus 2. Negative x squared minus 10x plus 2 all over x squared plus 2 squared, right? Now I have all these building blocks I need. So I'm going to fill this in. It says it's f prime at x, f prime at g of x. So f prime is 2u, isn't it? We can see clearly that u is x plus 5. So x plus 5 over x squared plus 2, right? And this is my f prime at g of x, isn't it? Times, well, what's the derivative of the inside piece here? And we did all that work down here. So times negative x squared minus 10x plus 2 all over x squared plus 2 quantity squared, which I see looks like hell, but it's going to work out good because we're almost there, right? So I'm just going to clean this math up. I'm going to get 2 times x plus 5, right, over x squared plus 2 times negative x squared minus 10x plus 2 all over x squared plus 2 squared, right? I know it's a pain, but this is kind of how you have to follow this thing up. So we get to that as we clean it up. I'm not going to, just to have it said, I'm not going to do all this crap. I'm truly not. Well, what I am going to do is what I can. I know that x plus 2, the quantity x squared plus 2, times the quantity x squared plus 2 squared is the quantity x squared plus 2 cubed. And my whole intention here is to admit that I'm going to do this math, but I'm not going to do it. I'm not going to expand this out because there's no reason to. Your professor should not expect you to follow this all out. What I probably will do is I'll pull a negative sign out of here and make this x squared plus 10x minus 2, so I don't have a lead coefficient that's negative, and I'll put this negative sign out there. That's all I'm going to do. All right? Look, I hope this is really helpful. This is a pain in the neck. It's not easy. You can definitely do this. If you want my advice on how to get great at it, my advice would be just keep working on it over and over and over, and you're going to get great at this. All right? Thanks for watching. If you have any comments, please make them. If you haven't already subscribed, please do.